All right, so in the last video, we quickly went over how to randomly assign. I just wanted to go over this a little bit more. This is the only case that you will use a coin flip. And why is this the only case you can use a coin flip? You only have two pairs, two males or two females that are the same age, they have the same fitness level. So when you flip the coin, you know one person's going to get one treatment and the other person's going to get the other treatment. So really this is the only time in matched pairs is when you're going to use a coin flip. So in this case, we'll say heads is caffeine and tails is caffeine free. What we'll do is we'll have the first subject flip the coin. If they get heads, they drink caffeine, and the other subject will drink caffeine free. If they get tails, they'll drink caffeine free, and the other subject will drink caffeine. Now notice when you're explaining the coin flip, you have to make sure that you state what happens when they flip the coin. You have to state if they get heads, they drink caffeine, and don't ignore the other subject. Make sure you state that the other subject will drink the caffeine free, and then make sure you state what will happen in the other case if they get tails. So you want to include both of those in your explanation of how you're going to randomly assign. Okay, so the other way to do a matched pairs experiment is basically a before and after. So the subject serves as the control. So they're basically paired with themselves. The subject is given both of the treatments. Since the order of the treatments can influence the response, instead of randomizing the treatment to one person or the other, we randomize the order of the treatment. So for the caffeine example, the subject can drink caffeine-free Coke one day, take their pulse rate, and then caffeine Coke the next day, and then take their pulse rates, and we compare the pulse rates after both experiments. Now, how would we randomly assign this? Like I said, we're randomly assigning the treatment, okay, to the experimental unit. So this is just an example of a hat method. Put numbers 1 and 2 on identical pieces of paper, put in a hat, mix it up, have the subject pick a number. Now make sure you state how they're going to do this. If they pick 1, first, they'll drink caffeine Coke on day 1 and caffeine-free Coke on day 2. All right, but don't just ignore that. You have to state what happens if they pick 2 first. If they pick 2 first, they'll drink caffeine-free Coke on day 1 and caffeine Coke on day 2. So just make sure that you include both of those. Now, this can also be done with a coin toss, and that's because if you toss the coin, they're going to drink caffeine one day and caffeine-free the other day. So you can ensure that it's equal amounts of experimental units within each treatment, so it's not breaking it up into different groups. Okay, so here's just an example. So the question is, are standing pulse rates generally higher than sitting pulse rates? So let's just see how we can answer this question using a completely randomized design and a matched pairs design. Now, what would this look like as a completely randomized design? Because the vocabulary is important, especially on the AP exam. They will say, please use a completely randomized design to create this experiment. Please use a block design. Please use a matched pair design. So you want to read it carefully to know what kind of design that you're creating. So remember, completely randomized is basically you're just starting out with one big group and then you're randomly assigning those groups to the treatments. So in a classroom, the teacher would randomly assign half of the students to stand and the other half to sit. Once the 2 treatment groups have been formed, students should stand or sit as required. Then they'll measure their pulse rates for a minute. Everyone will record their data. So completely randomized because I have one big classroom. I'm randomly assigning half the students to sit and half the students to stand up. All right, then they're recording their pulse rates, and we're going to compare them because we'll compare our pulse rates higher when you're sitting up versus sitting down versus standing up. So how would that look in a matched pairs design? Now there's 2 ways you could do this. All right. In this case, this is going to be a before and after, okay, where the subject serves as the control. So each would receive both treatments in a random order. All right. So every single student is going to do both treatments. They're going to sit and they're going to stand up. Each student will sit for 1 minute, take their pulse rate, and each student will stand for 1 minute and take their pulse rate. And then everyone will record their data. Now this will be assigned randomly, so that means that you would flip a coin. Every single student would flip a coin, and that would tell them, are they standing or are they sitting first? All right, so here's just some examples of why do we sometimes want to use matched pairs over a completely randomized design. So let's just take a look at these. Let's take a look at these 2 Fathom dot plots from the completely randomized design, which is up here, and a matched pairs design, which is down here. So if we're looking at these dot plots, what do we sort of notice here? Well, number one, note that the scales, okay, let's take a look at the scales. They're exactly the same on both of them so that we can compare them a lot easier. Now notice with the matched pairs, look at the difference in the pulse rates. It's all very clustered between 0 and 20 versus this one up here. All right, look at the differences between the sitting down and standing up. Now notice the pulse rates were somewhere from like 60 to 80. So I'm sorry, I said that incorrectly. So down here, this was the difference in the pulse rates. Notice how they're pretty clustered all around the same. Up here, we weren't measuring the difference. We were just looking at the pulse rates of sitting down versus standing up. Well, this is actually a lot easier to compare in this case because I can actually see the difference between every single solitary student and sort of notice that they're sort of clustered right here. Right around about, eight differences. Well, here we kind of see the variability in the pulse rates, but it's kind of hard to tell difference. Was the standing up really that much higher than the sitting down? Because they're kind of all clustered about the same. This one had a few higher, but can we really make a conclusion from that? The variability in the completely randomized design is much higher. So we're sort of going from 50 all the way up to 90. So that's a variability of 90. We're down here. The variability is only from about 0 to 20. All right. Due to the variability in this first one, because it was such a wide range of answers, we can't really make a conclusion that standing up causes an increase in pulse rate. All right. So if we're looking at this, we only have this few up here. Now, when we use the matched pairs down here, we can actually make the conclusion that standing increases the pulse rate. Well, why is that? Because we blocked, we were able to reduce the variability of the response variable. So when I say reduce variability, that means I'm not getting such a wide range of answers. All of my answers are sort of clustered in the same area. Since they're all clustered in the same area, it's easier for me to make a conclusion about whether or not standing up actually increases your pulse rates. Now, how would we use the matched pairs design to be completed using two subjects? All right, so over here, on the previous example, it was one person doing both. So how would I do that using two subjects? I'd have everyone in the class take their sitting pulse rates. Then I would range the students in order from the lowest pulse rate to the highest pulse rate. Now, remember matched pairs, I said they have to be similar characteristics. I'm going to put the two lowest pulse rates together, the next two, up until the highest two pulse rates have been matched. So they're similar pulse rates to begin with. Then I randomly assign each treatment by having the students flip a coin. You can flip a coin with matched pairs because you guarantee that one's going to get one treatment and one's going to get the other. If the first student gets tails, they'll take their sitting pulse rate and the other student will stand and take their pulse rate. And then what happens if the first student gets heads? They'll stand up and take their pulse rate, and the other person will sit down and take their pulse rate. So just make sure you're explaining how the randomization is going to occur in both instances. Now, think about this. How do you think the variability will compare to the blocked by subject matched pairs? So do you think it's going to be more variable? Are you going to have a more variety of answers when we do a matched pairs? Or do you think we're going to have less variability when we do two subjects versus matched pairs? So which is going to have more variability, the matched pairs or the matched pairs with a single subject or the matched pairs with two subjects? Okay, so most likely there's going to be more variability in the pulse rates than the blocked by pairs, but less variability than the completely randomized design. So there's probably, I apologize, this should say it's going to have more variability than the blocked by subject. Okay, so blocked by subject, that was the one that was one subject doing both of them. So since they're two different people, there's probably going to be a little bit more variability in the pulse rates. We're going to get a wider range when we're blocked by pairs than if we're blocked by subject. So that's sort of your before and after, or one subject doing both treatments. But it's going to have less variability than the completely randomized design. So this one's kind of in the middle. All right, so here's your summary. Just go ahead and take a minute and read that. I know this was a long section, so if you have any questions, please let me know.